All right, so we're back. I got cut off there. So now here is part 2. We're starting out at the rule of 70, and our answer at the very end was 10 years. So now it's your turn. This is question number 4. You need to figure it out and show me your work exactly how we did it just before. All right, let's keep going. Crude death rate and crude birth rate. So whenever you see the C in front of birth rate and death rate, so CDR and CBR, that means that you have the number of deaths that happened in your population divided by 1,000. So you're normalizing this so that it is actually a rate. And it tells you a little bit about your total population as well. So let's look at our problem. There are 20 deaths per 2,000 vampire bats in Costa Rica. What is the crude death rate? So CDR equals 20 deaths per 2,000 vampire bats. Ooh, what's happening there? This is a Halloween problem, right? Okay, so basically we need to turn this into deaths per 1,000. Okay, so we're taking this and we're going to make this formula right here look like this. All right. So when you do that, you're trying to, you want to show your work so that the reader, if this is on an FRQ or something, so that they know that you know what you're doing, that you know what CDR means. So if we were to do this, we'd have 20 and 2,000. We can simplify this into 10 deaths per 1,000 vampire bats. Okay, so that's one way of doing that, and that is definitely CDR. If we want to make this into just one number where we don't have the actual fraction right there, then we can simplify this even further into a decimal. CDR, 10 divided by 1,000 equals 0.01. Okay? So in this case, when you have a CDR, a crude death rate, you do not need to put a label on it. The crude death rate, CDR, equals 0.01, then we know that that means a rate. We know what that means. All right, so now your turn. This is question number 5. Make sure that you label, make sure that where necessary, and make sure that you show your work. Let's keep going. All right, now we're going to apply our crude death rate and our crude birth rate. In this one, I'm actually going to show you how to do number 6, and then you're going to apply this information to some questions afterwards. So let's figure this out. What are we looking at? Globally, our crude death rate is 15. CDR equals 15. And our crude birth rate is 20. CBR equals 20. All right, we need to calculate the number of years it will take for the population to double. Ooh, okay. So how are we going to do this? All right, to get this right here, our number of years it will take for the population to double. That's doubling time, which is 70 divided by our percent growth rate. So, do we have a percent growth rate right now? No, we have accrued death rate and we have accrued birth rate. But we can get a percent growth rate from these two numbers. And there's Lily again. So the growth rate using our CBR and CDR is equal to growth rate CBR minus CDR divided by 10. All right. Now, basically, we're doing the same kinds of things that we were doing in our other growth rate problems, but we're simplifying it because we have a normalized death rate and birth rate. We have something that includes information about our population. So we're going to take this and plug in our numbers. CBR equals 20 minus CDR 15 divided by 10. And that 20 minus 15 is 5 divided by 10. And that's going to be a growth rate of 5 divided by 10 is 5. All right. If I can get my pen to work over here. Sorry. All right. That's a 0.5. Now, because each one of these was divided by 1,000, okay? That's how they calculated this number right here and this number right here. When we divide by 10 right here, we're actually putting it into the form of a percentage. Okay, so you do not need to do anything to this number to turn it into a percent. It already is a rate. It already is a percent. All right, keep it the way that it is. Now we're going to take this number and put it into our doubling time equation. Doubling time equals 70 divided by our growth rate, which is 0.5. And remember, when we do this, we take out the percent. We do not move our decimal place over. We use it right as the rate that it is. So 70 divided by 0.5 is 140. And so that's going, remember doubling time is in years. So here, our question was calculate the number of years it will take for the population to double. That's our doubling time if these rates remain constant. It's going to take 140 years for our population to double. All right. Next, your turn. Okay. This one is a population growth rate. Oh, let's do one more growth rate problem. Why not? We're going to do a growth rate problem together, and then you'll have to do the last two after this. So we'll do this one together, and then you'll be responsible for number 8 and number 9. All right. World's population in 2000 was 6 billion. We're going to use another growth rate formula in order to determine this. Assuming a constant growth rate of 2%, in what year would the world population be 12 billion? All right. So what information do we have? We have the year. We have an initial population of 6 billion. We have a growth rate. So growth rate equals 2%. All right. And they're trying to ask us what year would the world population be 12 billion? So how do we figure this out? Well, the only way that we can do this is by finding a relationship between these two numbers. So 6 billion and 12 billion. 12 billion is double 6 billion. Okay, so we're going to use doubling time. Doubling time equals 70 divided by our growth rate. So this actually turns into a really easy problem. We already have a growth rate. So we're going to say 70 divided by 2. Remember, we take off that percent, and that's going to be our doubling time. 70 divided by 2 is 35 years. Okay, so now we look back at our problem. It says, in what year would the population be 12 billion? So this says 35 years. This is not our answer. Our answer has to do with the year 2000. So we have to say 2000 plus 35 equals the year 2035. That's the answer. Make sure that you always go back to the question and figure out what they're asking for. All right, so now you have number 8, your turn. This is definitely one that you need to answer, number 8. And number 9, your turn. You need to answer that as well. And that will be it. So number 8, I'm going to show that to you. You can pause it if you like. And then we're going to go to number 9 and show that to you, and you can pause it if you like. Now, last thing that I wanted to say, make sure that you are going through and showing all of your work, your labeling, and your work is neat enough so that I'm able to tell where everything is. We're going to go into this in more detail tomorrow, but for today, this should be a good start. So that is it for part 2 of your population math intro, and I hope you all have a very good day. Don't forget to do this and be ready for class tomorrow. All right. See you later, apes.